Okay, so good day, class. We're going to be talking about the A-star motion planning. It's a heuristic search algorithm. So this is the formula for it: Hn plus g of n, whereby h of n is the heuristic functions, that is the number of blocks required to reach the goal. Here's our goal. While g of n is the cost function, which is the number of steps taken from the start position. Where's our start position? Here. So this is our start position. So now we are going to iterate through the blocks to get our h of n and our g of n for each block. So this is the start position. So we're going to get our h of n. Our g is equal to 0 because g is the number of steps taken from the start position. We haven't taken any step from the start position, so g is still 0. And now h is the number of blocks required to reach the goal, right? So this is our goal. How can we get there? These red blocks are obstacles, but when we're counting for H, we're going to ignore them. So 1, 2, 3, 4. It take me 4 blocks to get to the goal, so H is equals to 4. And F is H of n plus G of n. So I'm going to get 4 plus 0, which is 4. Okay, so next, let's let our robot move to this block here. So when it moves here, G is going to count 1 because you've moved 1 step, right? And then your H, I'm going to just clean this up so it won't confuse us. It's going to be, so we're going starting from here. So 1, 2, 3, 4. It still takes 4 blocks to get to the goal. So it's going to be equals 4. Then F equals to 4 plus 1, which is 5. So now let's move here. We're going to have G equals to 1. Why? Because from this block to this block is only 1 step. So G is still going to be equals to 1 for this block. Okay. So next we're going to count for H. So how many blocks to the goal? Let's count. Let me erase this up. 1, 2, 3. So H is equals to 4 and then F is equals to 4 plus 1, which is 5. Okay. Let's go up again. Here G is going to be equals to, so we have moved 1, then 2. So G is going to be equals to 2. H is going to be equals to 1, 2, 3. H is equals to 3, which means F is equals to 5. Okay, let's move up here. Here G is going to be equals to, that is 1, 2, 3. G is going to be equals to 3. And now let's count for H. So it's going to be, we're starting from this block. So 1, 2, 3. Our position at that block. And that means H is equals to 3. That means F is equals to 6. You can see F is increasing. That's not a good sign, but let's go and see if it may decrease or something. So when you're here, you've taken 1, 2, 3, 4. Taking 4 steps. So G is equals to 4 here. And H is equals to, so how many steps to the goal? 1, 2, 3, 3. You can see F is now 7. This will not be the best part to follow because F is increasing. So this will not be the best part. So let's retrace back our steps to the start position and use this direction instead. Okay, so we are starting from the start position again and we're going in this direction. So if you go in this direction, G is equals to 1 because you've made 1 step. H is going to be equals to 1, 2, 3, 4. That means H is going to be equals to 4 here and F would then be equals to 5. Okay, let's go this direction. You can tell G will be equals to 2 because you made 1 and 2 step. H is going to be equals to 1, 2, 3, 4. That'll be 4. And F is going to be equals to 6. You can see F is increasing here. That is not a good sign. So this will not be the best path for us to take. So let's try and take this path instead. Here G will be equals to 1, 2. G will be equals to 2. H should be equals to 1, 1, 2, 3. H is equals to 3, and F is equals to 5. This is good. F is still remaining the same. So let's move here. G will be equals to 3. H is equals to 1, 2, 3. You have to pick the shortest path for H, and that's 3. For F is going to be equals to 6. You can see F is increasing, so this will not be the best path. So instead, let's use this path. G is be equals to what here? 1, 2, 3. So G is equals to 3. H is going to be equals to 1, 2, 2. And F is going to equals to 5. This is good. We're still on F equals to 5. Next, let's move here. G will be equals to 4. H will be equals to, you just have one more block to the goal. So H is just equals to 1. F is equals to 5. This is good. F is still 5. And next, we can just move to the goal, which is G is equals to, after 4, 5. H is equals to 0 because you are now at the goal. There's no more blocks to reach, required to reach the goal. So H is equals to 0. Let me say F is equals to 5. So therefore, you can infer that. So now we can infer from the diagram that this would be the best path. This is it neatly written. This is the best path for our robots to take. That is all for this question. Thank you for listening.